Swayam Prabha. Digital India. Educated India.
Good morning. I welcome you to this particular course, Geotechnical Engineering or Soil Mechanics. In civil engineering, we have 5 distinct group, and you can see that that is structural engineering, geotechnical engineering, water resources engineering, transportation engineering, and environmental engineering. Out of this, geotechnical engineering is one of the group, and under this almost every undergraduate course you will have 2 compulsory courses. One will be soil mechanics one will be soil mechanics, and most of the places this is the name, and some places it is having the name geotechnical engineering 1. And second course, compulsory course, will be the foundation engineering. And though right from beginning if you look the history in civil engineering, the structural engineering is the dominant section, and geotechnical engineering was developed quite slow. In fact, maybe after 60s it started doing reasonably well, but in our country it was still little late, and now it is substantially developed. But whatever civil engineering infrastructure we think about, but finally it has to go onto the soil. So, soil mechanics and foundation engineering is supposed to be a very important subject, and this whatever structure we think about, finally it has to go to the foundation. So, we have to design the foundation for building, foundation for retaining wall, foundation for dam, many other things. And so, we have to design those foundation elements, and for the design of those foundation elements, the basis is the soil mechanics. Unless you know the soil mechanics, you will not be able to design the foundation. Then so soil mechanics is the tools for designing the foundation elements, and this soil mechanics we will try to cover under this course entire soil mechanics, and you have number of modules. And this soil initially unlike other structural material which actually can be manufactured in the industry, in the factory, its quality can be controlled, whereas the soil is naturally developed and its properties generally cannot be controlled by us. Whatever available, we have to use it, and sometime if it is not suitable, then we need to go for ground improvement, etc. There are some other subjects will be there, or sometime in the foundation engineering different ground improvement techniques we will introduce. Otherwise, in this course only we will try to talk about soil mechanics, and since soil actually behave differently in different condition, or if the composition is different. So, if the composition is different, or if the moisture content is different, or many other issues, the age is less, or it is a older deposits. So, depending upon all those situation, its behavior also changes. So, because of that, the first we will look at the origin and classification of soil. If you can classify the soil, you will be able to tell many things about it. So, with this intention, we will try we will start this presentation of this soil mechanics course. So, first of all, I want to again soil actually is a general term, but the soil again will be user will be three different user will be there. There will be agricultural people, they use soil in a different way. They think they consider its nutrition values and many other factors, whereas geologists also consider soil as something different, and as engineer we consider soil as a material and its strength is most important parameter, and strength and many other things which we will discuss one by one. So, initially we will look at this agricultural and engineering soil just in general, and you can see if you look at a site, then every site we will see there will be a layer of organic soil and not more than 500 millimeter thick that is there, and that is considered as topsoil. And this topsoil mostly will have humus, that is decomposed vegetable matter, and after that we will have subsoil, that is actually portion of earth crust affected by current weathering and lying between the topsoil and unweathered soil below. So, this is the subsoil. So, these subsoil these are the different ways actually agricultural people can classify, but when we will classify the soil, definitely we have to classify differently, and that we will see that later on. But the at this point there is another layer in between sometime present, that is called heart pan, and that heart pan actually is in humid climates, humic acid can be formed by rainwater causing decomposition of humus, and this acid leaches out iron and alumina oxides down into the lower layer, where they act as cementing agents to form a hard rock like material, and it is difficult to excavate and does soften when wet. So, this is the heart pan, and this heart pan is very hard actually, and this we can see how where they form typically, and whatever I said, the topsoil, subsoil and all, these are the different this is actually topsoil, humus and all will be considered. This is actually subsoil, and these are the portion actually up to this is actually subsoil zone, and from the topsoil to the subsoil zone, when they are humic acid forming and it is leaching out and depositing somewhere here, that heart pan form, and this typical heart pan can be look like this if you excavate, and some places the heart pan will be visible and which is like this. And then agricultural engineering soil, once again the soil according to their classification, the soft geological deposits from the subsoil to the bedrock, which I have shown in the previous slide. In some soils there is a certain amount of cementation between the grains which affect the physical properties of the soil, and if this cementation is such that rock like material is produced, then that should be taken as a rock. And a rough rule is that the material can be excavated by hand tools or hand, then that will be treated as soil. And engineering definition, the geologist actually class all items of the earth crust as rock, whether hard or soft deposits, and civil engineers, whereas civil engineers consider rock and soil separately. And this rock and soil, actually rock also there are different types of rock possible, and how rock forms, and then from the rock how soil forms, these are all different situation and their process. And this is the typically I have projected here, this is rock cycle. You can see that in the very early stages it was a gas actually, and by cooling it became molten magma, and upon cooling of molten magma the igneous rock were formed. And this igneous rock, this is the way they are moving, this way it is moving, igneous rock. And then after weathering, because of the weathering of igneous rock, the residual soil can form, this is moving in this direction. And again residual soil, if it is by weathering and transportation, and there can be a sedimentary deposits can form, and that sedimentary deposits again further by compaction and cementation sedimentary rocks can form. So, this is the way. So, this is the way it can go from molten magma by cooling igneous rock, again weathering it is residual rock, the residual soil, from residual soil the transportation and weathering sedimentary deposits, and then by compaction and cementation it is reaching to sedimentary rock. Now, again instead of following this path, it can follow this path also. If it goes this way by heat and pressure, then metamorphism took place or metamorphism happened, and because of that metamorphic rock also can form. And again after metamorphic rock or metamorphism and formation of metamorphic rock, this can again further weather and transported and deposited, and then that is actually in this way it can form sedimentary rocks. And so, this is the one path is this to, so igneous, metamorphic, sedimentary, or igneous directly sedimentary through residual sedimentary soil and all, and again igneous, metamorphic and sedimentary. This is the two ways it can be formed. Again after sedimentary rock also it can happen the consolidation and cementation, heat and pressure, then again metamorphism can happen and it can reach to metamorphic rock. And here also this reversal also can happen. Here actually by cementation and compaction it reaches to sedimentary rocks, but again same way in this way weathering and transportation sedimentary deposit form, and again it come back to sedimentary rock. So, this way the different rocks that are igneous, metamorphic and sedimentary rocks can be seen in the in any site. If you go deep, then we may find somewhere igneous rock, somewhere we may find metamorphic rock, somewhere you may find sedimentary rock. So, these are the rock cycle. And also I missed another point, this metamorphic rock also directly can weather and transported, and then that will be sedimentary deposit will form, and then further compaction and cementation sedimentary rocks also can form. So, this is also another way. So, the cooling of molten magma, igneous rock, metamorphic to transportation weathering sedimentary deposit and sedimentary rock, or directly here by weathering and transportation directly to the sedimentary rock. So, this is the typical rock cycle actually, and if you excavate and go deep at any site, we may find this type of rock. Some site you may find igneous rock, some site you may find metamorphic rock, some site you may find sedimentary rock. So, rock actually rocks are made up from various types of minerals, and minerals are substance of crystalline form made up from a particular chemical combination. The main minerals in rocks generally we find are quartz, feldspar, calcite and mica. And geologists classify all rocks into three basic groups. They are igneous rock, sedimentary rock and metamorphic rock, which I have already shown in the rock cycle. Now, we will try to see the characteristics of each rock and a few names known rocks under each category we will try to discuss one by one. So, this is a igneous rock. The igneous rock actually this rock have become solid from a melted liquid state, and it can be extrusive and intrusive type. Extrusive igneous rocks are those that arrived on the surface of the earth as molten lava and cooled. And intrusive igneous rocks are formed from magma, molten rock that forced itself through cracks into rock beds below the surface and solidified there itself. So, this is the two categories again in the igneous rock itself, and they are intrusive and extrusive. And under this there are few names I can mention. The granite is one of the igneous rocks, basalt is another, gabbro is another, there are quite a few also. And igneous rocks example and characteristics, I have given three names. I am trying to give some characteristics, so that if you see the rock, then you can also identify them, whether it is igneous rock or whether it is sedimentary rock or whether it is metamorphic rock. Again, if it is igneous rock, what type of igneous rock, that also you can find. So, some basic characteristics are given here. Granite. So, granite if it is a generally grain structure will be very coarse and color will be light gray, and composition mainly quartz and orthoclase mixed with biotite, muscovite, hornblende and magnetite. So, generally if we see the physically a rock, we generally see the texture and color, and also by chemical analysis and other thing you can do, then other composition or crystal you can find out, and based on that we can confirm what type of rock it is, and granite is a very strong rock. Then next is the gabbro. Gabbro again its grain structure is coarse and color is dark, and mainly plagioclase and pyroxenes mixed with biotite and magnetite. So, again gabbro is not a very common rock, we granite we use, basalt we use, there is third rock is basalt, and basalt and gabbro they are almost similar composition wise. You can see basalt is grain structure is fine and its color is dark similar to gabbro, and composition also similar, mainly plagioclase and pyroxenes mixed with biotite and magnetite. Only by texture we can differentiate between gabbro and basalt, and granite and basalt, these two rocks are abundantly available and also used in various civil engineering activities. Then next is sedimentary rock. Weathering reduces the rock mass to fragmented particles, which can be more easily transported by wind, water and ice. When dropped by the agents of weathering, they are termed sediments, and these sediments are typically deposited in layers or beds called strata, and when compacted and cemented together, they form sedimentary rock. An example under this category shell, sandstone and chalk. And let us see their characteristics. Sedimentary rock example and characteristics, you can see limestone is one of them, and its generally group type, this is chemical, the weathering different agencies, by different agencies weathering can take place, that is actually chemical weathering happens to form limestone from sediment from igneous rock. And grain structure is generally usually fine, and brief description, mainly calcium carbonate present in the form of calcite or aragonite, and usually relatively soft and easily soluble in acidic solutions. So, this limestone can be identified by this, by seeing this. And sandstone, it is clastic. Clastic means it is a fragmented older rocks, and the grain structure is intermediate, mainly pressure cemented particles of sand. This is the weathering process actually, pressure cemented particles of sand, feldspar, hornblende, volcanic matter, by that those are actually the present in it, and it is porous, and sand rock mass is relatively easily crushable into smaller particles. And last one, there are many, but which I have listed here, shell, which are well known, that is shell. The shell again is a clastic, that means is a older rock fragments together, that is actually shell, and this texture is fine, usually fine, and mainly clay minerals and fine particles of silica, and two types of cementation can happen, cementation shell and compaction shell. So, these are by and large very briefly about the rock, and next we will try to see how again further weathering process this rock can transform into the soil. Then next is metamorphic rock. Metamorphic rock actually it is requirement, the metamorphism is required. So, metamorphism through high temperature and pressure acting on sedimentary or igneous rocks produces metamorphic rocks. The original rock undergoes both chemical and physical alteration. So, this will from the original rock whatever was there, it will be changed totally chemically and physically also. And some example is slate and quartzite and marble. There are many, but I have listed here, they are well known, and these three their characteristics let us see. Slate, the texture is fine and mineral arrangement is foliated, and brief description is it is metamorphized shell composed mostly of quartz and secondary mica, and is dense rock characterized by well developed tabular cleavage. So, you can see those cleavage if you look at the shell structure. Then gneiss, the structure is coarse, medium to coarse, and mineral arrangement is very poor and characterized by alternating bands of different colors and highly contoured shapes. Common minerals are mica present in it, mica, feldspar, hornblende and quartz. And marble, its texture is medium to coarse and mineral arrangement non foliated and formed by recrystallization of limestone and dolomite, and used as building material for decorative purposes and as source for lime. And you know that is a very essential, that marble is a very good building material, it can take very good polish, and because of that we use for flooring purposes and many other decorative purposes. So, these are very briefly how rock formed and how one rock to other rock form, and then a different composition, their identification procedure briefly we have discussed. Now, we will enter into how again from rock again transform into soil by again several processes like weathering, chemical processes or some other agencies. And soil formation from rock. Can I stop here?
হ্যাঁ স্যার স্টপ
বলেছি to some extent.
হ্যাঁ স্টার্ট করুন
Okay. So, briefly I have described the rock formation and transforming one rock to one rock, how by different physical and chemical processes this transform from one rock to other, and how I have given also some example of rocks from different categories and their characteristics. And now, next session I will try to describe how this from this rock again by different processes how the rock transform to soil, that I will discuss in the next session.